Stability analysis. What is stability? A system is stable if any bounded input produces a bounded output for all bounded initial conditions. Give the characteristic equation. Consider an nth order system whose the characteristic equation, which is also the denominator of the transfer function, is a of x equal to s bar n plus a1 s bar n minus 1 plus a2 s bar n minus 2 plus etc. up to plus an minus 1 s bar 1 plus a0 s bar 0. What are the goals for Routh-Hurwitz criterion? Determining whether the system is stable or unstable from a characteristic equation in polynomial form without actually solving for the roots. Routh stability criterion is useful for determining the ranges of coefficient of polynomial for stability, especially when the coefficient are in symbolic non-numerical form, to find K, mar and W. What are the necessary conditions for Routh stability? A necessary condition for a stability of the system is that all of the root of its characteristic equation have negative real part, which in turn require that all the coefficients be positive. The necessary but not sufficient condition for stability is that all the coefficients of the polynomial characteristic equation are positive and none of the coefficient vanishes. Routh formulation requires the computation of a triangular array that is a function of the coefficient of the polynomial characteristic equation. A system is stable if and only if all the elements of the first column of the Routh array are positive. Define root locus technique. It is a graphical method in which movement of force in the S-plane is sketched when some parameters is varied. The path taken by the root of the characteristic equation when open loop gain K is varied from 0 to infinity are called root loci. Direct root locus. K is between 0 to infinity. Inverse root locus. K is between minus infinity to 0. Define Nyquist stability criteria. The Routh-Hurwitz criteria is a method for determining whether linear system is stable or not by examining the location of the root of the characteristic equation of the system. In fact, the method determines only if there are roots that lie outside of the left arc plane. It does not actually compute the root. Consider the characteristic equation to determine whether the system is stable or not. Check the following condition. I plus g h of s is equal to d of s equal to an s bar n plus an minus 1 s bar minus 1 plus etc. up to an x plus a0 equal to 0.
Please subscribe our channel for more videos and education.